This presentation is made possible in part by Missouri Department of Agriculture, the Environmental Protection Agency, and University of Missouri Extension. In this module on identification of vulnerable areas in the environment, we'll review some of the best management practices for managing vulnerable areas. We'll examine the significance of soil type and hydrology when considering the use of pesticides. The ideal pesticide application will control pests and not harm the natural environment. Keep in mind that the recommendation of the pesticide label, in and of itself, may not be sufficient to protect the environment.
When we look at the pesticide label, there's a lot of information on there, but you need to make sure and look at certain key things. First, how hazardous is this? Make sure you look at the hazard labels. Once you look at that, then you come back and say, all right, what are the active ingredients? How do they react to the different things that I'm working with? So when we see that label, we're looking at what's the larger population going to be able to utilize, how well does it function under these kind of conditions. So the label, even though it's the law, does have some limitations.
Cool, we are going to harvest the broccoli today.
Before choosing a pesticide product for use in environmentally sensitive watershed areas, special consideration should be given to human health concerns, such as the potential for impact on public drinking water, recreational areas, and food and gardens. Ecological concerns include impact on endangered species and how pesticide levels can cause changes in the environment.
A couple of good examples of that is like chloridane, which used to be used for termite control around your homes. Does not break down very quickly. It stays around a long time. And even though it's been banned for a long time, we still find evidence of chloridane coming out into our river systems. Even though it's not harmful to humans, what we found is it created other issues with other types of wildlife.
Considering their role in land management and food production, farmers may be thought of as our nation's first line of defense in protecting human health and environmental quality. It's extremely important that farmers follow label directions, understand local patterns of water flow, know the setback distances from lakes, streams, and tributaries, consider weather conditions and the potential for change. They should be familiar with the characteristic of the soil and recognize what farming system is most effective for their specific and current conditions. It's important also to recognize those characteristics that define an area as sensitive or vulnerable.
We literally have about 7 different categories that we think of for water quality. Mainly what we look at are 3 or 4 of the top ones. Whole body contact, drinking water, fishing. So when we look at the ecological response to what water quality is, we need to take into consideration, is this watershed something that's got a major important aspect about it that needs to be protected more fully? Drinking water is a primary example. In the state of Missouri, we have over 100 drinking water reservoirs that feed our smaller communities. When we go about and look at what's surrounding those areas, in most cases, it's agricultural production. If you have a drinking water reservoir, you know that there are certain levels of pesticides that must be kept down so that we don't have a problem with it.
Consider best management practices prior to the selection and application of pesticides. Keep in mind any designated clean water areas. Note the particular soils and hydrology of the area, as well as its land use, geology, and topography. For example, the prevalent karst geology found in Missouri has a significant impact on that state's water quality.
Missouri has a large amount of karst geology, or fractured limestone. One of the things that makes this so important to the state of Missouri is that allows a lot of our water, surface water, to get into those cracks and move down into the lower groundwater aquifers very, very quickly. And as that water runs through that karst, and many times it goes ahead and starts dissolving that rock. So it creates sinkholes, it can create caves. But the nice thing about this karst and the thing about water is it always takes that path of least resistance. It's going to move from an area of high pressure to an area of low pressure. So it's looking for a way out between that rock. Again, Missouri has a tremendous number of live springs. Most of those are created because of that karst underlying topography that we have in the state of Missouri. One of the problems we have with that is it can move a lot of contaminants from the surface down through that karst because it moves so quickly, it doesn't get much treatment, and then it comes out somewhere else. The time frame that the water is within the soil, within the rock, all helps to determine how pure it's going to be or how much it's going to be cleaned by the natural environment.
The type of soil also affects water runoff and ultimately water quality.
Work that we've been doing in Missouri for, 22 years now, looking at how soils affect the transport of herbicides into our streams. And what we realize is that soils that have a very high, what we call runoff potential, in other words, rainfall, it hits that land surface and then easily washes off to a stream, those kinds of soils are the ones that have the most problems with herbicide contamination.
Fast-draining sandy soils have long been known to be vulnerable to the leaching of pesticides. But less recognized is the vulnerability presented by claypan soils. Claypan soils reduce the percolation of water into the soil and result in greater surface water runoff. Farmers have a series of best management practices options they can employ to reduce the potential for pesticide runoff. Some are mechanical, based on equipment use. Structural practices involve building or adding to the soil surface. Cultural practices are based on reasoning and management. Planted along field edges, grass buffer strips are effective in reducing pollutants. They should be designed with consideration given to the landscape, soil type, hydrology, and land use.
Some of the warm season grasses, so-called prairie grasses that were native to this region, may actually be better as grass waterways or buffer strips because primarily they're adapted here. But the important point is that they have very dense, extensive root systems that will explore the soil. The other aspect of this is that each crop releases different types of carbon compounds into the soil that stimulates certain segments of the microbial community to become active and contribute to the overall, let's say, degradation cycle of a particular chemical that might be in the soil. And a good example here is atrazine. We know there are several bacteria that have genes that specifically attack atrazine. It's a very complex system, and the soil, the microbes, and the plant root systems all work together to efficiently remove these chemicals.
Atrazine is a highly used pesticide that is regulated by EPA on the amounts that are acceptable for human and ecological health. Atrazine is very water-soluble, but also creates a strong bond with soil particles. In general conditions, label recommendations work well for controlling atrazine runoff, but in certain soil types, the normal practices that reduce pesticide runoff are not as effective.
You need to know, does that thing strongly bind to the soil? Because if it does, then that tells you it's probably going to move with the soil, and practices that control soil erosion are going to control the loss of that chemical. If, on the other hand, it's fairly soluble in water, doesn't bind very strongly to the soil, then it's either going to move in that runoff water or it could be subject to leaching to groundwater. So the type of practice you choose is based on knowing something about the properties of the herbicide you're using.
Matching the management practices with the soil type is one way of reducing the associated risk with atrazine runoff.
The particular soil type that you're on has to be considered, and the topography. I would say also the amount of crop residue that's remaining on the soil surface, the type of tillage that you're doing, whether it's some cultivation or versus no-till. A big issue now is whether you suspect you have herbicide-resistant weeds or not. Are you going to bump up the rate, or are you going to consider adding another chemical to hit those spots in the field that may be resistant to your primary chemical with a mixture of another?
Grass waterways are areas where grass is left to grow permanently, so that runoff water can drain into designated outlets without exposing bare soil to erosion. These should be designed and maintained for maximum efficiency in order to serve as an effective management tool.
And if grass waterway is wide enough, not only can it knock out most of the sediment, it can also reduce the pesticide nutrient loading, and it can also be then a habitat area for wildlife. If it's large enough, it can protect birds and everything else.
Terraces are an excellent structural tool for slowing water movement and reducing soil erosion.
Terraces, which were originally designed to reduce the volume and the velocity of water coming off the side of a hill, not only saves the soil, but because many of the pesticides that we use bond very closely with the soil, it also reduces the runoff of pesticides.
Careful planning is required to properly place the tile outlet of the terrace drain. It should never flow into a ditch or stream tributary. Rather, it should drain into a grass waterway or an area above the grass feed buffer. Riparian areas are the interface between land and waterway and represent one of the most effective management practices in reducing pollutant loading into streams and tributaries. Many farmers employ practices based on their historical use by the local culture.
One of the things we find is that based on the culture that you grew up in or that the farmer lives in, he may not want to do certain things. Strip cropping is a prime example. Some states, strip cropping is seen as a very viable option as a best management practice. Here in Missouri, we see very, very little of that. A lot of that has to do with the culture we grew up in. It has to do with the history of what we see as good management practices for this part of the state.
No-till planting practices reduce soil erosion, but heavy claypan soils cause more water runoff, and if atrazine sits on the crop residue after application, it mixes with the rain and has a higher tendency to run off.
I talked earlier about clay pans being a problem in parts of the state of Missouri. They're also been very valuable in keeping nitrates and pesticides from leaching into the groundwater. The closer to the surface that we have that groundwater, that water table, the more likely you are to get some kind of contamination in it. With this clay pan, we see that water doesn't go down and get into that groundwater quite as quickly. So much more of it runs off. So in that case, the clay pan has been very good at protecting groundwater, but now it's creating more of a problem with our surface water.
Label recommendations for atrazine are a first line of defense in reducing atrazine runoff. Incorporation into the soil helps reduce atrazine runoff, but soil erosion must be controlled to prevent atrazine from moving with the soil into streams and lakes. Equipment like the Phillips or Phoenix Harrow incorporates atrazine into the soil. With shallow incorporation adjusted to retain at least 30% crop residue cover, atrazine loss through the runoff of surface water is significantly reduced and soil erosion is minimized.
And for these high runoff potential soils, one of the trade-offs is to mix that chemical into the soil and get it beyond that depth that the runoff would, in a sense, extract it out of the soil. In other words, think of that runoff is running across the surface of the soil and it's picking up the chemical as it goes. Well, if we can put that chemical below that mixing zone, we don't have so much of it come off the land surface. But we need to do it in a way that we leave enough of that crop residue that you're not also causing an erosion problem. So we're trying to deal with two things at once at a minimum here, which is prevent erosion and prevent the herbicide loss.
Weather conditions can have a major impact on many of the practices that affect atrazine runoff. Careful scheduling and split application generally work well, but weather changes can result in reduced effectiveness.
One of the things it says on the label is you are supposed to look at weather conditions, understand what they mean and how that's going to affect what you're applying.
On the other hand, if you get out and you apply chemicals right before a rain, that's when your chemicals most easily washed off. And within the first 2 to 3 days of application is when it's most vulnerable to being lost.
A supply of clean water is essential to both human and environmental health. Keep in mind that water supplies are vulnerable to pesticide runoff and should be given careful consideration when selecting and applying a pesticide. Drinking water supplies are a particular concern.
Virtually, we have two primary sources of drinking water. We either have groundwater or we have surface water. In most cases, surface water seems to be much more vulnerable to the issues of pesticide contamination, nutrient contamination, even sediment contamination. Groundwater, in many cases, comes from a far enough distance and has been in the ground a long time, we don't see quite the issue. 67% of all of our population gets its water from surface water. Some of that's from the lakes, some of that is from the rivers. We need to know what's going into that water. When that rain falls, if it runs across an open field, what is it picking up? Because so much of our population does get its water from surface water, we put a lot of emphasis on what we look at as best management practices to control that amount of runoff from the surface and to try to keep it from getting into our water bodies and into our streams.
Additional management practices may be needed to prevent, reduce, or control atrazine runoff. These practices are considered to be moderately to highly effective. Incorporation of atrazine into the soil at a depth of 1 to 3 inches can significantly reduce herbicide runoff. Strip cropping can reduce the total herbicide load. Banded application at planting near the row to reduce total herbicide load. Precision farming. Technology to reduce application in setback areas. Irrigated land and water management. Timing and structural features to prevent water runoff. Riparian forest buffers intercept pesticides, nutrients, and sediment, and buffers streams. Many of these practices will be used in conjunction with other approved practices to deliver the maximum benefits toward the protection of human and environmental health.
There's a series of different best management practices that we look at to help mitigate different forms of pollution. When we're looking at pesticides, or even if we're looking at soil, we try to say what's going to work best. One practice is not going to do everything, but if we have a combination of practices, we can look at them to do several different things at one time.
What we've in fact come up with probably 12 to 15 different types of approaches. They have varying levels of effectiveness, but different ways that farmers can deal with the problem, because we don't see this as a one-size-fits-all problem.
Although there is no single best practice to meet every individual need to keep atrazine in place, the risk can be minimized through education and preparation. This flowchart presents the producer a means to determine what practices to consider when applying atrazine in fields with claypan-like soils. Suggested best management practices are identified depending on the tillage system that the producer prefers. Successful and effective management requires a comprehensive knowledge of one's fields and keen awareness of specific areas that require greater care and represent the potential for ineffective application. This is knowledge to empower better management decisions that result in greater protection of both human and environmental health.
I think it's important for people to understand that this is not, about, say, environmentalism for the sake of environmentalism. In other words, we understand farmers have to make a living, they have to continue to be profitable. So our challenge is coming up with solutions that fit within their systems, that allow them to stay profitable, but also consider the fact that these chemicals staying on your field is not just an environmental issue, it's also a money issue. You're directly losing the cost of the chemical, plus you're losing yield potential. So it's in everybody's best interest that this stays on that farmer's field.
So when we start looking at the ecological value of a watershed, Not only do we think about endangered species, whether it's plant or animal or birds, but then we say, what other uses do we have with this water? You need to make sure you're doing everything and following that label most appropriately for your drinking water watershed. If you aren't, you're not following the label recommendations and you're not doing the responsible thing to protect other people.
Remember, the label directions are the law. But in some situations, they could be insufficient to protect human and environmental health. The more you know about your farm, the better you can determine what to do to protect human and environmental health and maintain economic viability.
When we talk about any form of use, pesticides and water quality, when we talk about best management practices, some of the things we need to keep in mind is how is this going to be important not only for the environment, but what happens with the farmer or the producer when we're looking at making decisions. It's got to be something that's got to be viable for him. It's got to be something that fits into his farming operation. If we can't do that, all the rules and regulations in the world are not going to work. So we have to talk with those producers. We have to find out what they're doing. How can we become a part of that system without causing them to have to purchase a large amount of equipment, without having them to step outside the time frame that they have available, and what can we do that's going to make it more available to them, make it more viable to them, and make it much more usable.